Hello. We're doing one outside today, so we'll see how this goes. Sorry if my dog starts freaking out or something. Okay, so this is algebra. Algebra is an Arabic word that means like taking stuff apart. And it's the whole point of the class. So today's the day we first start doing it. And we kind of like, for now, all algebra means for your purposes is sometimes we use letters instead of numbers. Okay, we use letters to represent quantities or amounts, and to express general relationships. So something equals something times something or something like that. So a lot of vocab today, and a lot of just cleaning stuff up. We're not even to like solving for x yet. That's the next section. So a letter that represents a number from a set of numbers is a variable, like x. X is the most common one. Don't know why, just is, but we can use any letter. We can even use Greek letters like pi that aren't even in our alphabet. And when I say from a set of numbers, for now, just assume that means all numbers, the set of all numbers that we know about. Okay. So as opposed to a variable, a constant is a fixed number. So it doesn't vary. We know what it is. 5 is just 5. So it's a fixed number like 5, or a symbol that represents a fixed number, like a famous number like pi. And that's what I mean by we can use Greek letters, except, to be clear, that particular Greek letter doesn't represent a variable. It represents 3.14, whatever. Okay, let's make this clear. Here's an equation you've probably seen from Einstein. It has to do with the theory of relativity, which is over my head. So the famous equation is E equals mc squared, probably one of the more famous equations. And in that, if you didn't know, E and M represent energy and mass, which change. You might be saying, how can mass change? Well, theory of relativity. So those vary, but C doesn't. C is a specific thing in that equation. C is the speed of light. C stands for constant, literally, and the speed of light does not change. So there you go. We have 3 letters, 2 of which are variables that can change, and 1 of which is a constant, which can't. When we say expression, we just mean a bunch of algebra. So it can have variables in there, constants, grouping symbols like parentheses, and mathematical operations like addition and multiplication. So an expression is not an equation. An equation has an equal sign in it and says that this stuff is equal to this other stuff. And usually with an equation, you would want to solve it. With an expression, it's just a thing that exists, and all we can really do for it for today is just clean it up and simplify it. Like that. That's an expression. Notice there's no equal sign in it. So for now, that's the difference between an expression and an equation. This doesn't equal anything. It just sits there. So now we need, well, first let's work with expressions. So when we say evaluate, you'll be given like a number that x equals. And for now, just think plug in is the word we usually use. So when I say evaluate, when I say something like this, evaluate x squared minus 3x plus 2, so take that expression and evaluate it for x equals -2. We mean plug in -2 for x, or substitute is probably a more technical term. Okay, so we're going to take -2, plug it into that expression. If that reminds you of like a function, if you know what that is, then yeah, this is exactly the same thing. Okay, so we got to be careful with negatives. It's -2 in parentheses squared. Remember, that's different than -2 squared. Minus 3 times -2, and then plus 2. So the plus 2 doesn't change when we evaluate it, right? Because it doesn't have an x in it. It exists independent of x. And then clean it up. So this, like if you left it like this, you're technically right, but you wouldn't get marked right because we want to make that simpler. So -2 squared is -2 times -2, which is 4. We have a minus 3 times a minus 2, so that's going to be a plus 6, and then we have the plus 2. Right, so it's 4 plus 6 plus 2, which is 12. Okay, so when you evaluate an algebraic expression for a certain value for x, you're just going to get a number. More vocab. Okay, a term is either a constant or the product of a constant and 1 or more variables raised to a power. That sounds more complicated than it really is. I'm going to show you an algebraic expression, and I'll show you what the terms are. Okay, 3x cubed minus y squared over 4 plus z minus 10 is an expression. It's got x's, y's, and z's in it. That's fine. And those four thingies are the terms. So the first term is 3x cubed. The second term is minus y squared over 4. Notice the minus is part of the term. The third term is z, and the fourth term is minus 10. So it can have a constant in it and a variable to a power. This thingy here is called a polynomial, but you don't really need to know that yet. The numerical part is called the coefficient. So for this term here, the 3x squared, the coefficient of that term is 3. The coefficient of this term is actually negative 1/4, and that's a little different because you don't really see the 1 there. But if you think, okay, just it's what times y squared, you see that it's negative 1/4 times y squared. Okay, so that coefficient is minus 1/4. If you don't see a coefficient, then it's just 1. Right? You could think about this as being 1 times z, but you don't need to put the 1 there because it doesn't do anything. So the coefficient there is not 0. Right? If it were 0, then the term would just vanish. It's 1. If two terms have the same variable part, so in other words, the same variable to the same power, those are called like terms. So 3x squared and negative 5x squared, for example, are like terms because they both have an x squared. They just have different coefficients, but they are, in that sense, like. And these things aren't. So they have, notice they have the same coefficient, 7. They have the same variables, a and b, but the variables are to different powers. So those are not like terms. You could call them unlike terms. Either way, we can't do the thing that we want to do, which is combine them. So before we get into combining like terms, let's talk about this guy. Very powerful property of algebra that never goes away. It's the distributive property of multiplication. We can just call it the distributive property. It's technically called the distributive property of multiplication over addition, but whatever, here it is. There it is. A times, in parentheses, b plus c equals ab plus ac. So that's why it's called the distributive. It's like we distribute the a to both of the summands. Things you're summing are called summands. So you take the a, you times it by the b, and then you add the a times the c. So you can think of that as like a formula you have to memorize, or just think about it as just a thing that exists and that's how numbers work, and you have to internalize it. I would rather phrase it that way. Okay, so you take the term on the outside of the parentheses and you multiply by every term in the parentheses, and they're adding. So it's not like AB times AC, it's AB plus AC. For example, take this and use the distributive property on it. So really the instructions for all the stuff in this section are going to basically just be simplify. And as soon as we get more moves, I'll clarify exactly what the word simplify means in this context. So negative 1/4 times parentheses 12x minus 16. Go ahead, do it. So you're going to multiply the negative 1/4 times the 12x, and then it's going to actually be minus the negative 1/4 times the 16. So I didn't say it or write it, but in the distributive property, I think it's pretty obvious. If this is a minus sign instead, then it works exactly the same. It's just this is a minus sign instead, right? It kind of follows. Okay, so that's what I said, negative 1/4 times 12x minus 1/4 times the negative 16. So that stuff's going to simplify as well. So you can, if you're confident, you can kind of skip this step, but for now, I'm just going to say don't. Just be on the safe side and write out every single little thing you're doing on the test. Okay? So minus 1/4 times 12x is negative 3x, right? Because the coefficients sort of combine. And then minus 1/4 times negative 16 is just positive 4. And that's as far as you can go. The 3x and the 4 are not like terms. So like some people are tempted to just keep simplifying and simplifying, compacting, but like there's a time when you have to stop. And that's when just there's no like terms. Okay, so here is combining like terms. So if you have that, which sometimes you will, then do it. We like to combine them. And the thing that lets us do this is the distributive property. Whether or not you really know you're using it, you are kind of using it backwards. Right, so this a simple one is just if I give you 4x plus 9x, you might just be saying, hey, Professor Patrick, isn't that just 13x? Yes, but let's just see like why you can do that. That's why. Because, right, if the distributive property works this way, it works the other way as well. So you can take the 4 plus 9 and put them in parentheses in their own little thing and have the x on the outside, and then you all know that 4 plus 9 is obviously just 13. So there you go. You might know that it's 13x, but now I'm telling you why. So remember, the commutative property is the thing that says when you're adding, you can move terms around. It doesn't matter which order you do it in. So if it suits you to take an expression and move stuff around in order to do this, then do it. In fact, you probably don't even have to physically move the terms around to do it, but for now I'd like you to. You don't have to tell me, no, I'm using the commutative property. You just have to use it. But for now, like, kind of show me what you're doing. So, like this. 5xy squared plus 7x squared y plus 3xy squared minus 8x squared y. Oh boy. Lots of x's and y's. And again, for now, yeah, like this is a polynomial. And, the graph of this would actually be a 3D surface, but we don't need to get into any of that stuff yet. For now, the instructions are just combine like terms. So simplify by combining like terms. So notice that the 5xy squared and the 3xy squared are like terms, and the 7x squared y minus 8x squared y are also like terms. Okay, so we're going to move them around like that. I'm going to take the 3xy squared, the stuff's easier to write than it is to say, and put it here. And then I'm going to take the 7x squared y and put it here. So I'm essentially just switching these two terms around. And I can do that, right? Commutative property. And now we see that, okay, these two like terms can just be combined using this move into 8xy squared. And then we have a plus 7 minus 8. So 7 minus 8 is negative 1. So that's going to be a minus 1x squared y. Except you don't have to write the negative 1. Right? So again, that's what you're really doing. Even if you skip this step, even if you eventually you can skip all these steps and jump straight to the answer. Okay? I believe in you. But for now, when you see this on a test, I do want to see all these steps. Sorry. Okay, because 5 plus 3 is 8, and then 7 minus 8 is negative 1, but you don't need to put the negative 1. Now, if you put the negative 1 there, would I mark it wrong? Yeah, assume that I would, okay, since you asked. Assume that I would, because really, the whole goal of this is that we're simplifying. So having anything extraneous that doesn't do anything is not really simplified. Birds. It'd be like if you put a plus 0 on the end of this thing. Is it wrong? No, but it's not. It's unnecessary, and the point is to have this as simple as it possibly can. Now, if you wrote this the other way around, if you wrote this as negative x squared y plus 8xy squared, that would not be wrong. That's the exact same thing because, again, of the commutative property. Okay, so your answer could be a teensy bit different than your neighbor's answer and still be right. All right, and then our last thing is if the expression you're given has a bunch of parentheses and stuff in it, you'll probably have to use the distributive property forward first to get rid of them, and then combine like terms. Okay, so for now, when the instructions are just simply simplify, this is what that means. It means get rid of all parentheses and then combine all like terms. Combine everything possible. But what you should be left with at the end is an expression that there's absolutely nothing you can do to. Okay, so the word simplify gets used a lot in mathematics, but it doesn't really mean anything like mathematically, because one person's simple is another person's this could be simpler to me. So before now, like for this exam, I'm going to say simplify this, and this is what I mean, okay? And I don't think about this as I have to memorize what all he means. Just get it to a place where there's nothing else you can do to it, and then kind of know when to stop. Okay, for example, you will 100% see something a lot like this on the test. 1/2 times parentheses 6x plus 4 minus 1/3 times parentheses 12 minus 9x. And these instructions are just going to say simplify. So it's on you to know what I mean. Okay, so start by using the distributive property forwards to get rid of all the parentheses. Okay, so they all got to go. So order of operations is coming into play here, right? It's parentheses first. So get rid of the parentheses by calling it, okay, that's 1/2 times 6x plus 1/2 times 4 minus 1/3 times 12 minus 1/3 times negative 9x, like so. And then, okay, you're going to actually multiply all those terms together. So 1/2 times 6x is 3x, 1/2 times 4 is 2, minus 1/3 times 12 is minus 4, and then minus 1/3 times negative 9x is positive 3x. All right, so we're left with 3x plus 2 minus 4 plus 3x. And you're certainly not done because there are like terms in there that can be combined. So I know it seems like doing too much, but I'm going to use the commutative property to rearrange this as 3x plus 2 minus 4. So just for now, I'll say just for this exam, do this step for me. Okay, just do it for me. In the future, obviously, you all know what 3 plus 3 is in your head, and 2 minus 4. You don't need to put it next to each other to know that. But, err on the side of showing me too much work. Okay, so now we can combine. So 3x plus 3x is 6x, 2 minus 4 is negative 2. And then you're done. So again, a big part of this, and this will go forever, is knowing when to quit. I have this problem in my calculus classes, is that people just want to just keep simplifying and simplifying, and it's like not everything in life is like that. The 6x and the 2 are not like terms. They don't jive with each other. So you're done, right? You're done when there's no more like terms to combine. All right, so quick sort of story problem in the form of a geometry problem. The length of a certain rectangle is L feet, that's an L, and the width is L minus 10 feet. And so L is a variable. It could be anything. A rectangle could shrink and grow depending on what L is. So what am I asking you? I'm going to ask you to find and simplify. So give me an expression for the rectangle's perimeter and the rectangle's area. Now, sorry, my neighbor's using a power tool. This is not a geometry course. I don't expect you to know complicated formulas from geometry, but I do expect you to be able to figure out, what a rectangle's perimeter and area is. If you even know what those words mean, then you know. Perimeter means distance around, so you add up all the sides. Area means how much stuff is in it, so you multiply the length and the width. So always draw a picture, and that's one of those life lessons that will never go away in math. Your instructor, at least, is going to always want you to draw a picture because that's how we humans visualize problems. So you don't have to be Leonardo da Vinci over here to draw a picture of a rectangle. I'm just doing it with my finger on my screen, so mine's not going to be that great either. There is a rectangle, work of art, right? Okay, so you draw the shape and then you label stuff. So this is L, because it's longer, and this is the width over here, and it's L minus 10. That's a 10. I always draw my L's in cursive in math. I don't even know if you guys still learn cursive in school, because if you don't, it looks like a 1 or an I. So good habit to get into. If you're using L as a variable, draw it with a little cursive swoopy thing, because otherwise I might think that it's not an L. Okay, so go ahead, draw the rectangle. It's about to disappear. And now I just want nice, clean, succinct expressions for the rectangle's perimeter and its area. So you can even go farther in your labeling because rectangles are symmetric. So if that's L, this is L. And if that over there is L minus 10, well, then this over here is also L minus 10. Okay, so the perimeter is just all that stuff added together. The area is the length times the width. Let's see what that looks like. Okay, so the perimeter is just the sum of all four sides. L plus L minus 10 plus L minus 10. I put those widths in parentheses. Not because I really needed to, but because they're still kind of grouped together. So now we just simplify that expression. So take the parentheses away. And then in one move there, so that's, maybe a little lazy, but I think that's allowed. I just put all the L's together and I put all the 10s together. So I just got rid of the parentheses. They weren't doing anything. Put all the L's out front, so there's 4 of them all day. And then put the -10 and the -10 next to each other. So now you see in one step we have, this is 4L minus 20. Okay, so now if I told you the length is, 30 feet or whatever, then you could say it's the perimeter is 4 times 30, which is 120 minus 20, which is 100. So the perimeter is 100 feet. So it just makes that calculation simple. Area, same thing, almost even easier. The area is just length times width. So L times L minus 10. The distributive property tells us that that's L times L minus L times 10. And then that expression can be made simpler because an easier way to say L times L is L squared. And then minus L times 10, the way we write that, the way we've been writing that, is 10L. So there it is. The nicest answer for this problem is L squared minus 10L. A couple of notes. If you wrote L times 10, it wouldn't technically be wrong because the multiplication is commutative, so L times 10 means the same thing as 10 times L, but don't write it that way. I would actually probably mark it a little bit wrong. And it's just another thing that's just like politeness. We're just used to seeing constant then variable. So the coefficient comes first. So since I'm trying to get you in good habits, so write it as 10L. And then another good habit, notice that I wrote it as L squared minus 10L and not minus 10L plus L squared. If you wrote minus 10L plus L squared, I couldn't really mark that wrong, but again, get in the habit of writing like this because the powers descend. So we want the bigger powers of L to come first. We generally want the orders of power to be descending. So again, just good habits so that your math teacher down the road in harder classes, thanks me for teaching you good habits and it doesn't, aggravate them when you write stuff weird. Okay, so that's the area. So now let's actually do that. So if the length is 30 feet, find the perimeter and area. And now it's easier to do that because you have nice, concise little expressions for them. See? So it came in handy to use algebra. So now I'm asking you to evaluate these two expressions for L equals 30. So for the perimeter, just plug 30 into that, 4 times 30 minus 20. And then since this is technically a application, which is the word we use instead of story problem because you guys don't like story problems, 4 times 30 is 120, and then 120 minus 20 is 100, and I want you to put a unit. So instructions would say include units, but if you didn't put feet, I would take points off. Okay, so the full answer there is 100 feet of perimeter. For the area, you're just going to plug it into this formula instead. See, these are little formulas that you made. Congratulations. So it's 30 squared minus 10 times 30. 30 squared is 900. 30 times 30 is 900. And then 10 times 30 is 300. So it's 600, right? 900 minus 300 is 600. And then the units for area, we haven't really talked about this yet, but units for area are square feet. And I think you probably know that. So I'm getting a little ahead of myself by even including this problem, but I think you know when you have a square unit that the units for it are units squared. So it's 600 square feet. I'm going to stop now. Thank you.